Okay, so switch it on. Does it work?
Hi everyone, we are good. Sorry. Hi everyone, we are going to start the Michael Fötsch talk from libspotify about adding music to Python. Please switch off your cell phones and enjoy.
Hi, hello. So thanks for coming. I will talk about a number of APIs that allow you to put music inside your Python applications. Thanks for the introduction. I know my name is hard to pronounce. I tried to get a different one for the conference. Didn't get it in time. So my name is Michael Fötsch. I work as a software developer at Spotify in Stockholm in Sweden. That's where the largest R&D center of Spotify is located. The three music APIs I will talk about are libspotify. That's the project I work on at Spotify, so I'm one of the libspotify developers. a.k.a. It's a very interesting music intelligence API, as they call themselves, and Last.fm. You probably heard about Spotify, but just in case you didn't, Spotify is a subscription-based music streaming service. So you pay a little less than 10 euros a month if you go for the premium subscription, and you have instant access to the 20 million songs we have in the catalog. You can play them as many times as you like on all your devices. We're adding new songs all the time. According to our websites, we add 20,000 songs every day. I didn't check, but I guess it must be correct. Users created 1 billion playlists, and we're currently available in 28 countries, including Italy, so some of you might be using the service already. We have clients for the desktop. It's available on Windows, Mac OS, Linux, also on Android, iOS, iPhone and iPad. There's even a version for the BlackBerry, if you want to use that. And we offer a number of APIs to developers. One of those APIs are the Spotify apps. These are HTML and JavaScript-based apps that run directly inside the desktop client. Here's an example, the Music Match Lyrics API, or Lyrics app. This is an HTML view inside the desktop clients. It has some bindings to the Spotify APIs. You can use them in this case. Just uses the track title and playback position. Another very simple thing is the play button, a little widget that you can put on a blog or website and embed a playlist. When you click the play button on that, it will start playback in the desktop client. And the third one is libspotify. That's the one I will talk about today. It is a C++ library and allows you to write the full-featured Spotify client. Everything you need to develop such a client is in there. High-quality streaming, everything for playlist management, searching artists, album and track metadata. It also does scrobbling to Last.fm and sharing via Facebook. There are a few limitations and downsides. One of the downsides, it is a C++ library. So that means, since it's not an open source library, it only works on the platforms that we support. There's quite a number of platforms though, so it should work on most popular devices. And some features missing from the current version of libspotify. The in-client apps that we just saw, like Music Match, they don't work in libspotify. The latest social and discovery features aren't in there, or in there yet. And there is no support for the Spotify radio, even though I will show you later on how you can create radio-like functionality using libspotify and the a.k.a. You need a premium account and an API key. It's a very simple process to get the API key. Go to developer.spotify.com, fill in the web form and you get the key immediately. You can download it in binary format, which is used by the Python bindings. It's available for Windows, OS X, iOS, Linux, for various CPU architectures. And it also runs on a Raspberry Pi. We have versions for hard float and soft float variants there. The Python bindings I'm going to talk about come from the MoPD project. I hope I'm pronouncing it correctly. This is a music server that plays local tracks and also contains a plugin for Spotify. This is not maintained by Spotify, but Spotify developers have submitted patches to the past. It works really well. It's easy to get started with. Talking about easy to get started with, so I will show you some snippets of source code. You don't have to type them. I won't ask questions about them later. So I just want to show you the session manager wraps everything in PySpotify. You create the session manager, connect to the session, and that will do the login. And from that point on, the connect doesn't return until you log out from Spotify. Everything else is handled through notifications or callbacks that you register. In this case, when the user is logged in, the logged in callback will be invoked. Other callbacks in there, the music delivery itself, or various error states, or when metadata, meaning like artist names, song titles, whatever, becomes available, those callbacks will be invoked. Let's show another example, loading the user's playlists. You notice I added another base class, the Spotify container manager. Container in this context is the container of the user's playlists and playlist folders. As soon as the user is logged in, we register another callback with the playlist container, and when the playlist container is loaded, callback is invoked and we can iterate over the user's playlists and do something with them. You might have noticed that I check whether the playlist itself is loaded. That's kind of a recurring theme. Like everything happens asynchronously in the background. So your app can do other stuff while in the background all that data is being downloaded. It is pretty fast usually, but since libspotify also works on small hardware devices with bad network maybe, can take a time, so there are always callbacks invoked when data becomes available. Let's continue there and load the user's playlists. Here in the container loaded callback, we can iterate over the items in the user's playlists, and let's say they are not loaded, then you register the playlist state changed callback. The playlist state changes when the playlist is fully loaded. So this is invoked, playlist fully loaded, and now we can finally iterate over the tracks. So granted, this is a bit more complex than your usual web API that just gives you a huge JSON with all the data in it. But as I said, it's made for hardware devices that have slightly different requirements. PySpotify makes it really easy to work with it, actually. So let me just mention that playlists can be organized in folders. That's also fully supported in libspotify. Maybe you didn't know that there are playlist folders, but they exist. You can create them in the desktop client, and I think the mobile clients also have support for them. Yeah, that's what my playlist container looks like when I took the screenshot. As you can see, number of folders, number of playlists in there. The next example involves searching. The search API gives you paged results, so you can tell it the search offset and the number of items you want to retrieve. You will get artists and albums and tracks and playlists all at the same time. However, I didn't figure out how to access the actual playlist results in PySpotify, so that seems to be missing, or at least I didn't find it in the wrapper. And there are search term suggestions for misspelled search terms, you get like, did you mean that other better spelling? Once we're logged in, we can use the API, searching for something, specify a callback that will be invoked once the results are available. And yeah, you can see asking for 5 tracks, 5 albums, 5 artists. That's what it gives you. It gives you 5 artists, 5 albums, 5 tracks that match the search term, and also the total number of results so that you can page through them. So now that we have all these playlists and tracks, we might want to play them. There's the music delivery callback that gives you the raw PCM audio samples. So you don't need to do any MP3 decoding or OGG decoding or whatever. You just get PCM samples. And in Spotify, there is a module called Audio Sync, which wraps various sound drivers, also OSS, Port Audio, GStreamer. All you need is an implementation of the music delivery callback and forward the samples into the audio sync. So the audio sync is imported here. And then session load, audio start, session play, and it will play the music.
Does libspotify take care of making sure that you have audio samples in time, and that they're delivered in time so you don't get hiccups in playback?
It does what it can to ensure that. Of course, if their network is really bad, then you might get stutter. But there are buffering strategies inside libspotify, so you don't have to buffer anything. And in fact, you shouldn't buffer anything. So just forward it to the audio sync, and there will be a libspotify internal buffer that's also adjusted according to your connectivity in some way. Before you can play the track, it must be fully loaded. Again, that's our recurring theme here. Wait for it to be fully loaded. So here's the full code. While it's not loaded, I'm just waiting for 100 milliseconds here. That's quite okay. In this case, here's a little detail. When you receive a track from a user's playlist, that track might not actually be available in your region, for example. But there might be an alternative to that track from another album that is available in your region. So there's this if statement here. If this is linked to another track, then let's load that track instead. It's unfortunate that it has to be done, but that's the way with regional restrictions. Various bit rates are supported from 96 kilobits per second all the way to 320 kilobits per second, and that's pretty good quality actually. Sounds really well, or really good, I think. Well. So before I go to the next API, let's talk real quick about Spotify URIs. You might have seen them in the desktop client. If you right-click a track or an artist or an album, you get Spotify URIs. Here a track URI, for example. And well, those you can put back into the search box, and it takes you directly to that item. And it will also allow us to map the Spotify URIs to the IDs of other services, like Echo Nest or Last.fm or iTunes. Spotify link class, not much to it. It converts from a Spotify URI and gives you the Spotify URI of any object, like a track, album, artist. Let's go right to the Echo Nest API then. Echo Nest call themselves the world's leading music intelligence company. I think it sounds really good as far as a company description goes. They claim to have over 1 trillion data points on over 30 million songs. And those data points that they have go from track names and artist names and the albums and artists released and the production years and whatnot. They also give you similar songs and similar artists. Even audio analysis-based data, like the tempo of the song, the mood, the genre, down to the level of individual beats and bars in the song, which is really interesting data. They have an HTTP and JSON API, and of course Python wrappers. GitHub.com/econest/pyeconest also require an API key, but again, really easy to get started. For non-commercial use, you don't pay anything for that, and you can prototype your applications using that. So here's the song search example for Econest. Here I'm searching for songs that are between 120 beats per minute and 160 beats per minute by artists that were active in the 1980s and 1990s. I want a minimum danceability of 0.6. 0.7 would be too much for me personally, but I can deal with 0.6. And I don't want totally obscure artists, so I'm asking for artist familiarity 0.5. I don't know what it means, like every second person knows them, or not entirely sure. Yeah, and right when you perform the search to speed up things later, you can specify that you will need the Spotify URIs. So that saves you another round trip later. So as part of the first search results, you will receive Spotify track URIs for these search results. And then go through the tracks and print their Spotify URI. There is a slight difference. Spotify URIs are just Spotify : something, and in Econest they are Spotify minus, I think this means worldwide or something. So that has to be replaced. And that's that. Here are the search results for this. Please check whether the danceability is actually as high as I specified. For each song I might get several tracks. That's because, well, maybe one of them is the album where it appeared, and the other one might be a compilation or something like that. So several tracks for the same song there. Among the attributes that you can use in your searches are, of course, title and artist and genre, or whether it's a live or studio recording, the duration, loudness, time period. They even have what do you call it? Like GPS coordinates of where the artist composed the track, I guess. That's what it must be. Speechiness, musical key, all kinds of data. Not all those data points are available for all tracks, though. So not all of their 30 million tracks have this very detailed audio analysis data. Next example, retrieve artist biographies and reviews. So we start off with a Spotify artist URI, again inserting this -ww, and then just check the biographies and reviews attributes, and there you go. There we are, the most commercially successful pop group of the 1970s.
Yeah. We know.
Well. Similar artists, very interesting feature. We can specify any number of artists, and then the similar artist search will return a list of artists that are similar to that group of artists. Here are the buckets again to specify, okay, we want to have the Spotify artist URIs, iterate over them, and that's it. Turns out if you start with two famous Swedish bands, Roxette and ABBA, the most similar one is Ace of Base. I guess that makes a lot of sense. Next up are taste profiles or catalogs. Those two terms are used interchangeably in the Econest documentation. So a taste profile is basically the collection of songs or artists that let's say that you listen to, or I mean, nothing stops you from creating a catalog of artists that you never want to hear. And then you can use that as a seed in various APIs and specify, okay, I want to have stuff that's according to that taste, or I want to have everything except that. It gives you event recommendations, and you can see the radio station with it. And yeah, as you know from Spotify radio, you can thumbs up and thumbs down individual tracks, and that will refine your taste profile. So the steps are, you create the catalog, can create quite a lot per API key, 1,000 of them. You add songs and artists. I don't think there's any limit to how many songs and artists to put in there. Or, yeah, I guess there is, but it's high. And then you can use the catalog in searches and queries, and later on give the user an opportunity to add a rating or choose favorites or ban an individual artist or track. Here's the example for catalog creation. With a list of Spotify track URIs, just create the list and put it into the update method. That will give you a ticket that you can check. This update might take a while. For me, it was always updated immediately when I tried this, but yeah, you can wait on the update to be completed, and then you can use that. Here to create a static playlist of type catalog radio, seed it with that taste profile. So that will make sure that the tracks that you get are not exactly what's inside your catalog, but similar in musical style or things that you might like. We have the Spotify track URIs again to ask for that. Yeah, it gives you a number of tracks in their Spotify URIs. For refining the catalog, you can update the play count whenever a user listens to that and plays it. You would call play. If the user skips it, you would call skip. Well, that would probably tell a.k.a. that, yeah, maybe it doesn't like that so much. You can add your favorites or ban an item or give a rating from 0 to 10. So that's that. Taste profile is quite interesting, and yeah, combined with libspotify, you can develop really interesting radio style applications. Let's go to the audio analysis data. As I said, it has information about the song tempo and the individual beats and when the song fades in and when it fades out, so really useful. Not for every track. However, a.k.a. can perform analysis on MP3 tracks that you upload to them. So you can upload an MP3, they will do the analysis, and sometime later that data becomes available. You shouldn't use the libspotify APIs for that. I'm pretty sure it's against the terms of service to upload the Spotify tracks to a.k.a. But if you happen to own that album, can upload and have it analyzed. Yeah, call the get analysis method, and once you do that, you have access to all these things like the bars and beats and tempo and danceability. I guess the hardest part of that will be to figure out what are you going to do with this kind of information. But there is some inspiration of what you can do. a.k.a. has another project called the a.k.a. Remix. They call it the Internet Synthesizer. There is a number of really interesting mashups that people created using that API. One of the interesting ones is the Infinite Jukebox. So that's a song here. So as it plays, the playback position will move down here, and these arcs are places where you could jump to another position in the track, because based on the audio analysis, it's possible to make a seamless transition to that other place in the song. So as you play this, it will go on forever, and with a certain probability jump randomly to another place in the song, and you can listen to that same track for 24 hours. I accidentally did that with Call Me Maybe while I was working on the slides. It does go on forever. And, yeah. Or another thing, the Bohemian Rhapsody chord. That's a kind of synthesizer based on little pieces of the Bohemian Rhapsody by Queen. It's also quite interesting. You should check those out. They're definitely very interesting things you can do there. At a.k.a. remix. Yeah, so the next and last FM, but not least, I will talk about the Last FM API. You might know the website. You create your user profile there, and then from all supported clients you can scrobble, which means as you play tracks, you send the information to Last.fm, and over time Last.fm has a pretty good understanding of your musical taste and can give you recommendations. There are also some social features. You could find people who have a similar taste in music, or get event recommendations and things like that. They have a Python API on Google Code. Again, you need an API key from them to use that. Here's an example now playing. Log in to the Last.fm network, and then you can update the now playing information, in this example based on artist name and track title. That might not be unique, so you might want to have an actual Last.fm track object or a MusicBrainz ID of the track, and that will show up in pretty much in real time on your profile. Here it says scrobbling from PyLast. It's a bit hard to read, and shows the world what you're listening to. I also accidentally favorited some Iron Maiden track and shouted to System of a Down because I didn't remove the lines from the sample code. So make sure to change my sample code if you don't want anyone to know that you listen to Share. To map Spotify URIs to Last.fm IDs back and forth, I'm using the Econest. Because why would you not want to use 3 different APIs for that? Last.fm is able to use MusicBrainz IDs, and Econest has the so-called Rosetta Stone project, where they convert to and from a multitude of streaming services and music services in general. So you can take a Spotify IDs or iTunes IDs or other streaming services are available. It gives us the MusicBrainz ID, and from that the Last.fm track can be created. The user's library, so that's a screenshot of their webpage. You can see, okay, these are my top artists, or the top artists in a certain time period. It's quite interesting from time to time. Go back and see, oh, what did I listen to a year ago? Oh yeah, I listened to Linkin Park. That's when I accidentally left them on repeat while my phone was in my pocket. So they will never go away from that list. There's a user object that gives you the library object, and that has, for example, the get artists method. So going through the 5 top artists there. Or you can compare your user profile to any other Last.fm user. It gives you like a numeric score between 0 and 1 of the similarity, and the list of shared artists. By the way, Last.fm is also a Spotify app, runs inside the desktop client. Should try it out. There are 100 or over 100 Spotify apps, correct me if I'm wrong, something like that. Doing things like recommendations and create playlists, or yeah, there are all kinds of different apps available in there. So that's more or less the end of this talk. I want to, since you're here, you might be interested in developing applications around music. So I'd like to invite you to check out spotify.com/jobs. We're always looking for good Python developers. We have offices in Stockholm, Sweden, in Gothenburg, There's a slightly smaller development site in New York, and last time I checked, there were also job offerings in San Francisco. So if you're interested in that, please go there. And Yuki told me that we have few sunglasses left, so when the talk is over, you might be able to get one at our booth in the lobby. So yeah, thanks a lot. That was it. Any questions?
In addition to the native clients, you also have this online implementation of Spotify. I don't know if it was Flash or not. Do you have an API for commanding that or embedding that in your own web applications?
There is the Spotify play button at this point is the only thing that's available. That's this widget that allows you to embed a single track or a playlist or an artist in a website. There is no official API for the web player yet. But by the way, we have a web player now, so you should give that a try.
Hi. I think someone, maybe it was Holger, I don't know, someone in another talk mentioned that for some of the functionality, I think maybe if you click that play, that widget, it said you have to have the client installed. And someone mentioned that you guys do some really funky stuff to detect that, like you run a local web server or something like that. Could you go into that?
Yeah. So I think that was in the keynote by Armin Ronacher. Yeah, the desktop has a web server, or the desktop client opens up a web server, and this Spotify play button that I talked about, and also the Facebook integration, where you can we also have a play button there on your Facebook profile if someone shares Spotify playlist. That will talk to this local web server, and yeah, for that, at least that's what we heard there at that talk. There was a certificate created for localhost so that it actually works with SSL and everything. So yeah, that's a pretty clever way of doing things.
So then you could talk to your own local Spotify client using a web server.
Yes. Yeah, the question was whether you can use that to talk to the desktop client. Yeah, that's what the play button does. It allows you to pause and play and change the track and things like that.
Do you use Echo Nest behind the scenes?
In an earlier version, if you used the Spotify radio, it would say powered by Echo Nest or something. So we did use their radio service. In the meantime, there is no powered by Echo Nest anymore. So we have our own recommendation engine there. I do know that we sync the track URIs with Echo Nest. Beyond that, I can't really say what it's used for or whether at all it's used.
Yeah, well, question about the library is where you have to check if it's loaded, and couldn't that be handled by the library itself, that the callback's called when it's loaded?
Yeah, I talked to one of the developers of the Mopidi project, and they have something in the works, like an abstraction on top of what's currently there in PySpotify to make it even easier. But of course there are always two sides to that. By making it easier, or by doing that automatically when you ask for a track and then it will wait, then you suddenly have a blocking call. You might not want to have that if you're embedding into hardware. So the libspotify itself has a very low-level API, and then on top of that, of course, it would be interesting to provide a really nice Pythonic abstraction on top of that handles things like this.
There's a restriction that you can only use one client with one user account at one time, right?
Yes.
I was wondering, are those restrictions the reason that the libspotify is actually closed source, or are there other reasons behind that? And couldn't you open source it to make it easier for people to make implementations in other languages?
I guess there are many reasons why it's not open sourced at this point. The restriction that you're talking about, that's handled server side, so you will, the other clients will not be able to continue playing if playback is in progress on another device. That's the restrictions that's set in the contracts we have with the labels, I guess. As far as open sourcing libspotify is concerned, we do have open source Cocoa bindings for libspotify, but the core libspotify itself is, for the foreseeable future, closed source.
Could you give more information on the technologies used to build a desktop client? What kind of the HTML5 JavaScript client, and what kind of engine you are using behind the scene? And do you have any plan to release it as an open source framework for building other kind of desktop applications?
That's a good question, but I have to say I don't work with the desktop much. So I know how to compile it, how to clone the Git repo and compile it. I've seen the source code, but actually what it uses, someone asked me yesterday whether it uses Qt or whatever, Qt from, to be honest, I don't really know. Thank you very much.
The next talk will be 12:15, and it is about, doesn't matter.